Hi students, welcome to Sunil's tutorial. I'm Sunil Nirvani and today we'll be doing this chapter called as matrices. We'll continue with what we were doing in the last lecture. Find the inverse of cos theta minus sin theta 0, sin theta cos theta 0, 0, 0, 1. Right? I have to find the inverse of this matrix. Now, first of all, you will say let A be equal to the given matrix, that is cos theta minus sin theta 0, sin theta cos theta 0, 0, 0, 1. Right? Now, you will say that we know that A into A inverse is I. A is nothing but cos theta minus sin theta 0, sin theta cos theta 0, 0, 0, 1 into A inverse is I. I is identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay. Now, I need to make this number as 1. I need to make the number in the first position as 1. How do I make the number in the first position as 1? We know that sin square theta plus cos square theta is 1. Right? So, I can say R1 into cos theta will give you, I already have a cos theta here. So, multiply that by cos theta, that will become cos square theta plus R2 into sin theta. I have a sin theta there, multiplied by another sin theta, that will give you sin square theta. So in that case, this is going to be R1 into cos theta, cos square theta plus sin square theta, 1. This is going to be minus sin theta cos theta plus sin theta cos theta, 0. Minus sin theta cos theta plus sin theta cos theta. Minus sin theta plus minus sin theta cos theta plus sin theta cos theta is 0. 0 plus 0, that's 0. Sin theta cos theta 0, 0, 0, 1 into A inverse R1 into cos theta. 1 into cos theta is cos theta plus 0. So this will be cos theta. Then 0 plus sin theta. 0, 0, 1, 0, 0, 0, 1. Okay. Now I need to make the number in the second position as 0. Where is this number in R2? What is the number sin theta? What is the complement of sin theta minus sin theta? Right? R2. R1, sorry. So now this is going to be 1, 0, 0. Sin theta minus sin theta 0, cos theta minus 0, because sin theta into 0 is 0. I have sin theta into R1, 0 minus 0 is 0, 0, 0, 1 into A inverse is cos theta sin theta 0. Now this is going to be 1 minus sin theta cos theta. No, R2 is 0. 0 minus sin theta cos theta. So minus sin theta cos theta. Right? Then this is going to be 1 minus sin square theta. 1 minus sin square theta and 0, 0, 0, 1. Now I want to make this number as 1. So I am going to divide R2 by cos theta. If I divide R2 by cos theta, I will get 1, 0, 0, 0, 1, 0, 0, 0, 1 into A inverse is cos theta sin theta 0 minus sin theta cos theta divided by cos theta will give you minus sin theta. 1 minus sin square theta, see here, this was sin theta cos theta divided by cos theta will give you minus sin theta. 1 minus sin square theta is cos square theta. Cos square theta divided by cos theta is nothing but cos theta 0 and 0, 0, 1. Therefore, I can say that A inverse is cos theta sin theta 0 minus sin theta cos theta 0, 0, 0. Fine, do we get this thing here? Next, let's see the next one. Find matrix X such that 1, 3, 3, 1, 4, 3, 1, 3, 4 into X is equal to 7 minus 3 minus 3 minus 1, 1, 0 minus 1, 0, 1. I have to find matrix X. Now, if I have to find matrix X, what I have to do is convert this value into identity matrix. To convert this into identity matrix, the number in the first position has to be 1. The number in the first position is already 1. The number in the second and the third position have to be 0. Right? Where is this number in R2? What is the number 1? What is the complement of 1? Minus 1. R1. Similarly, I want to make this number as 0. Where is this number in R3? What is the number 1? What is the complement of 1? Minus 1. R1. 1,
so what exactly does this mean?
This is your equation that you make in order to make the given terms as 0. You have a set of rules which you have to follow in order to get that as identity matrix. Right? Now 1 minus 1, 0. 4 minus 3, 1. 3 minus 3, 0. Now 1 minus 1, 0. 3 minus 3, 0. 4 minus 3, 1. Into X 7 minus 3 minus 3. Now minus 1 minus 7. Minus 1 minus 7 is minus 8. Then you have 1 plus 3, 4, 0 plus 3, 3. Then you have minus 1 minus 7, minus 8, 0 plus 3, 1 plus 3. Now the number in the fifth position has to be 1, it is already 1. The number in the sixth position has to be 0. Where is this number in R1? What is the number 3? What is the complement of 3 minus 3? R2. So in that case this will be R1 minus 3 R2. 1 minus 0. 1. 3 minus 3. 0. 3 minus 0. 3. 0, 1, 0. 0, 0, 1. Into X is 7. No. R1 minus 3 R2. So 7 minus of minus. Minus into minus plus. 8 3s are 24. 24 plus 7, 31. Then you have minus 3 minus 12. Minus 3 minus 12 minus 15. Then you have minus 3 minus 9. Minus 3 minus 9 is minus 12. Minus 8, 4, 3. Minus 8, 3, 4. Now I have to make the number in the first position as 0. In order to make the number in the first position as 0, I want to make the number in the first position as 0. Where is the number in R1? What is the number 3? Complement of 3 minus 3. R3. Right? So in that case, you will get this as 1 minus 0, 1. 0 minus 0, 0. 3 minus 3, 0. 0, 1, 0. 0, 0, 1. into x is 31 minus 24, right? So that is going to be 7 again. Now minus 15 minus 9, right? Minus 24, then you have minus 12 and another minus 12, so that's minus 24. This is minus 8, 4, 3, minus 8, 3, 4. Therefore I can say yes.
So it was 7, so it's 31 minus of minus 8, right?
31 minus of minus 8, right? So 31 plus 24, 30, 50, 55. This is going to be 55, right? So in that case you will get your answer of x as 55 minus 24 minus 24 minus 8, 4, 3 minus 8, 3, 4, right? That is going to be your value of x, right? Now once you have this, next let's see another sum. A is equal to, now find A such that A into 7, 6 minus 1, 4, 2, 3, 1, 3, 0 is equal to 4, 2, 3, 1, 3, 0, 7, 6 minus 1. Now, let us assume that this given value is b. Let b be equal to 7, 6 minus 1, 4, 2, 3 and 1, 3, 0. And let's assume that the answer is C. That is 4, 2, 3, 1, 3, 0, 7, 6 minus 1. I'm assuming those two values to be B and C. Now first let's find out the determinant of B. Determinant of B. How do I find out determinant of B? 7 as it is. If I take 7, I cannot take the first row and the first column. If I take 7, I cannot take the first row and first column. It is principal diagonal minus the other diagonal. So this is going to be 0 minus 9. Then minus 6. If I take 6, why did I take minus? That's a part of the formula. If I take 6, I cannot take the first row and the second column. So in that case, principal diagonal minus the other diagonal plus minus 1. If I take minus 1, I cannot take the first row and the third column. So 4 3s are 12 minus 2. So this is 7 9s are 63 plus 6 3s are 18. This is 10 minus 10. That's minus 73 plus 18. 53, 55, minus 55, which is not equal to 0. So the first thing that you have to find out is that determinant of B is not equal to 0. Why did I do that? Because I can use this equation that 1 into B should give you B. 1 into B should give you B. 1 can be written as 1 0 0 0 1 0 0 0 1 into B. I'm not substituting the value of B here, but I'm substituting the value of B on the right hand side. So value of B is 7 6 minus 1 4 2 3 1 3 0. Now look at your sum. Look at the question. Where do I want the 4 2 3? I want 4 2 3 in the first row. Where do I want 4 2 3? I want 4 2 3 to be in the first row. Where is 4 2 3, guys? 4 2 3 is in the second row. That means what should I do to get it in the first row? Interchange R2 and R1, right? Interchange R2 and R1. If I interchange R2 and R1, I'll get this as 0 1 0 1 0 0 0 0 1 into B is 4 2 3 7 6 minus 1 1 3 0 right? Now, again let's look at the sum. Where do I need 7, 6 minus 1? I need 7, 6 minus 1 in the third row. I need 7, 6 minus 1 in the third row. Where do I have 7, 6 minus 1 in the second row? Interchange the second row and the third row. If I interchange the second row and the third row, I'll get 0, 1, 0, 0, 0, 1, 1, 0, 0 into B is 4, 2, 3, 1, 3, 0, 7, 6 minus 1. Right? Now, in that case, I get this is nothing but 0, 1, 0, 0, 0, 1, 1, 0, 0 into B. We know that the value of B is 7, 6, 7, 6 minus 1, 4, 2, 3 and 1, 3, 0 is equal to this 4, 2, 3, 1, 3, 0, 7, 6 minus 1. If I compare this with my given sum, okay, compare this equation with the given sum. A into B gives you C. A into B gives you C. And here I have this number into B gives you C. That means the value of A has to be this. I'll say therefore A has to be 0, 1, 0, 0, 0, 1, 1, 0, 0. Fine, do we understand this? Next, let's see another sum, guys. A is equal to 2, 4, 1, 1. You have to show that A square minus 3A minus 2I is 0. Right? Now, first of all, A square is nothing but A into A. Right? A square is 2, 4, 1, 1 and 2, 4, 1, 1. There's one more thing to that question. You have to prove that it is equal to 0 and hence find A inverse. Okay. So first I'm finding out A square. A square is nothing but A into A. How do you multiply rows into columns? Rows into columns. 2 2s are 4 plus 4. 4 2s are 8 plus 4. 2 plus 1. 4 plus 1. This is nothing but 8, 12, 3, 5. Okay, now let's start with LHS. LHS is nothing but A square minus 3A minus 2I. A square is nothing but 8, 12, 3, 5 minus 3A. A is 2, 4, 1, 1 minus 2I. 1, 0, 0, 1. Right? Let's see this. This can be written as, I just substituted the values, guys. 8, 12, 3, 5 minus, take 3 inside, so in that case this will be 6, 12, 3, 3 minus 2, 0, 0, 2. Right? Now, add the like position numbers. If I add the like position numbers, this is 8 minus 6 minus 2. 12 minus 12 minus 0, 3 minus 3 minus 0 and 5 minus 3 minus 2. This is nothing but 0, 0, 0, 0 which is equal to 0, which is my RHS. Right? LHS is equal to RHS proved. LHS is equal to RHS proved. Right? Now, once you have done this, you have to find out A inverse. Right? Now, we have just proved that A square minus 3A minus 2I is 0. I'll say multiply by A inverse. If I multiply by A inverse, if I multiply the equation by A inverse, in that case I'll get A square into A inverse minus 3A into A inverse minus 2I into A inverse is 0. A square into A inverse, laws of indices, A raised to M into A raised to N is nothing but A raised to M minus N. Right? So in that case that should be equal to A. So that should be an A raised to 1. Now A means A raised to 1. A raised to 1 into A raised to minus 1. A raised to plus 1 minus 1. A raised to 0. Anything raised to 0 is 1. And in matrices 1 is written as I. Minus 2. 1 into A inverse is 0. So therefore I can say that A minus 3I is equal to 2A inverse. The value of A is 2411 minus 3I 1001 is equal to 2A inverse. So you will have 2411 minus 3003 is equal to 2A inverse, in which case I could say that 2 minus 3 minus 1, 4 minus 0 4, 1 minus 0 1, 1 minus 3 minus 2 is equal to 2A inverse. I could take 2 common here. If I take 2 common, then I'll get this as minus 1 by 2, 2, 1 by 2 and minus 1 is equal to 2A inverse. 2 and 2 gets cancelled. So I'll get the value of A inverse as minus 1 by 2, 2, 1 by 2 and minus 1. Right? So that's how you get the value of A inverse. Next, let's see a couple of more sums of different types.
So,
yeah.
Is it possible that we get a matrice, the first one which is a 1 by 1 and the second one a 2 by 2?
You have to, that depends whether you have multiplication or not. See, whenever you have multiplication of matrice, suppose if A is a 2 by 1, then B has to be 1 by any number. The columns in the first matrix should be equal to the rows in the second matrix for multiplication of matrix to be possible. Matrices can be multiplied only if the column in the first is equal to row in the second. Right? Next. Let's move on to the next one, guys. A is equal to 3, 4, minus 4, 3 and B is equal to 5, 6, minus 6, 5. You have to prove that A plus B into A minus B is equal to A square minus B square. Right? Let's see the sum. Now the first thing that I'm going to do, guys, is I'm going to find out AB. How do I find out AB? A is 3, 4 minus 4, 3 and B is 5, 6 minus 6 and 5. Multiplication. How do you multiply? Rows into columns. So this is going to be equal to 5 3s are 15 plus minus 6 4s are 24. That was first row into first column. Now first row into second column. 6 3s are 18 plus 5 4s are 20. Now second row into first column. Minus 20 minus 18 minus 24 plus 50. Right? So in this case you will get this as minus 9, 38, minus 38, minus 9. Right? Once I get the value of AB, the next thing I'm going to do is I'm going to find out BA, for which I'll have to write B first. 5, 6, minus 6, 5, 3, 4, minus 4, 3. How do I do multiplication of matrices? Rows into columns. So in that case, this is going to be 5 3s are 15, minus 6 4s are 24, 5 4s are 20, plus 6 3s are 18, minus 18, minus 20, minus 24 plus 15. I multiplied rows into columns, right? In which case I will get this as minus 9, 38, minus 38, minus 9. Right? What we observe, guys, is that AB is equal to BA from equation 1 and 2. I can say from equation 1 and 2, I can say that AB is equal to BA. Guys, remember that in matrices it is not necessary that AB will be equal to BA. Here it is just a coincidence that AB is equal to BA. Once I get that, let's start with my LHS. I have to prove that A plus B into A minus B. So first I have to multiply A with the second bracket. So that will give me nothing but A square minus AB. Then I have to multiply B with the second bracket plus BA minus B square. First I multiplied A with the second bracket, then I multiplied B with the second bracket, right? A square minus AB. We found out the value of AB to be minus 9, 38, minus 38, minus 9, plus BA. We found out the value as minus 9, 38, minus 38, minus 9, minus B square, plus the matrix minus the matrix. Plus and minus cancel, so I'll get this as A square minus B square, which is my RHS. That's what I have to prove, that LHS is equal to RHS. Right? Next, let's see another sum, guys. A is equal to A, B, 0, 0. B is equal to B, 0, minus A, 0. You have to show that. You have to show that A plus B the whole square is equal to A square plus B square plus BA. A square plus B square plus BA. Right? Now the first thing that I'm going to do is I'm going to find out AB. How do I find out AB? A, B, 0, 0. B, A minus A. Sorry, B, 0 minus A, 0. How do I do this? Rows into columns. Right? So in that case, this is going to be AB minus AB. That's first row into first column. First row into second column is 0 plus 0. Second row into first column is 0 plus 0. Second row into second column is 0 plus 0. So I get the value of AB as 0, 0, 0, 0, which is nothing but 0. Now let's start with LHS. LHS is A plus B the whole square. Now A plus B the whole square is nothing but A plus B into A plus B. A plus B the whole square is nothing but A plus B into A plus B. First multiply A with the whole second bracket, so that's A square plus AB. Then multiply B with the entire second bracket, so that's BA plus B square. But we found out the value of AB to be 0. So in that case, this is going to be A square plus 0 plus BA plus B square. If I rearrange this, this is A square plus B square plus BA. That's my RHS. That's what I have to prove. That A plus B the whole square is A square plus B square plus BA. Next, let's see another sum, guys. A is equal to 1, 2, minus 1, minus 2, and b is equal to a 2, b minus 1, and they've given me that a plus b the whole square is equal to a square plus b square. You have to find out a and b. Right? Let's see this. How do we do this? Now, I can say that first let's find out AB. How do I find out AB? 1, 2, minus 1, minus 2 into A, 2, B, minus 1, rows into columns. Right? So in that case, this is going to be nothing but A plus 2B, 2 minus 2, minus A minus 2B, minus 2 plus 2. So in that case, you will get this as A plus 2B, 0, minus A minus 2B, 0. I got AB. Next, BA. BA is going to be A, 2, B minus 1 and 1, 2 minus 1 minus 2. Right? Let's see how do we do this? Rows into columns. So in that case, this is going to be nothing but A minus 2, 2A minus 4, B plus 1, and next you have 2B plus 2. And do we get this thing clear? Now in this case, we've got this, but they give me that A plus B the whole square is A square plus B square. Now A plus B the whole square is nothing but A plus B into A plus B is A square plus B square. You first multiply A with the whole bracket, that's A square plus AB. Then you multiply B with the whole bracket, BA plus B square is A square plus B square. A square gets cancelled, B square gets cancelled. Right? That means I can therefore say that AB plus BA should be equal to 0. But the value of AB you found out is A plus 2B minus A minus 2B 0 0 plus BA. BA is A minus 2, 2A minus 4, B plus 1, 2B plus 2 is 0. Right? Add. If I add this will be A plus A, 2A plus 2B minus 2, 2A minus 4, minus A minus 2B plus B is minus B plus 1, and this is 2B plus 2 is 0. 0 can be written as 0, 0, 0, 0. So in which case I can therefore say that 2A minus 4 is 0, like position terms. Therefore 2A is equal to 4, A is 2. Then 2B plus 2 is equal to 0, 2B is equal to minus 2, B is equal to minus 1.
That's okay, you can use any equation. Right?
Yes, you could have used any equation, but this would be a longer equation. I would need simultaneous. Here I get the answer more easily, therefore I use these equations. Right? This finishes this sum. We'll stop this here for the day. Thank you very much.